Okay, welcome back to Intro to Statistics. So we're going to talk about the non-standard normal distribution. This is section 7.2. Okay, now z-scores used to be a really important part of this class before we had the fancy calculators. Okay, and the formula for z-score is going to be z is equal to, okay, I think we actually did this a much earlier in the class too, but z is equal to x minus mu divided by the standard deviation. What this is going to do, it's going to turn all of our not normal distribution or not standard normal distributions into standard normal distributions. This is going to give us back, this is going to transform this thing into having a mean of 0 and a standard deviation of 1. Okay, because we're going to divide it by it. We're dividing by what the standard deviation actually is. So what if I went through and I did something like, I want one standard deviation out. Okay, so if I had a mean, say, of 10 and a standard deviation of 2, okay, what I would do here, I would say, okay, well, what if I had an x value of 1 standard deviation away from the mean? So 10 plus 2 equals 12. So to calculate the z-score, we're going to do 12 minus 10 divided by 2. That's going to be 2. 12 minus 10, right, is 2. Divided by 2, it equals 1. So we get a number that is 1 standard deviation away from the mean. Kind of what we did there. Okay, if it's 1, how about we do 2 lower then? What if I say my x value is equal to 14, or is not 14, I want to go 8. I want 2 standard deviations below the mean. Say 8. About 2 standard deviations. How about we go down 1 more? Sorry about that. Why don't we go with 6? That way x equals 6. So we're going to say 6 minus 10 divided by standard deviation 2. 6 minus 10 is going to be minus 4. 4 divided by 2, right? We end up with minus 2. We're 2 standard deviations down. So what the z-score is telling us is how many standard deviations away from the mean are we? So z is equal to the number of standard deviations away from the mean. Okay, and in a normal distribution, okay, the way that this thing looks, okay, that's what the normal distribution looks like, and we'll talk about that a little bit, is that most measurements are grouped up around the middle, or grouped up around the mean, okay? And the further away from the average you get in steps of standard deviation, so in this case, I would be taking steps of 2 standard deviations out, okay? The less frequent those observations are going to be. Okay, that makes sense, right? If we have that the average male, sorry, I don't know the average, I don't know average American female height, but the average male height is my height. That's 5'9". Okay, 69 inches. Okay, there's not, I mean, there's a lot of men who happen to be 69 inches. There are fewer men that happen to be 72 inches, and fewer men that happen to be 73 inches, 74 inches. And the further you get away from that average, the fewer men that there happen to be. And the same thing on the other side, right? There's a lot of 6'9" or 5'9", maybe 5'10", 5'11", 5'8", 5'7". But how many jockeys do we have, right? How many men who we have that are like 5'5", 5'4", 5'3", and they're just fewer and fewer and fewer of them. Okay, and that's one of the big things about normal distribution is the further away you are from the average, the less probability that we're going to have to be, that we're going to observe that phenomenon. Okay, and again, we measure these in terms of standard deviations. Okay, so if you had a very large standard deviation, say I was making something and I had a standard deviation of like 10, well, then I have to step in steps of 10. Okay, so if my mean was, we'll say 100, and I have standard deviation of 10, now we're looking at something that looks like IQ points, right? So there's a lot of people that have 110 or 100, and then from 90 to 110, there's going to be a lot of people. Okay, if we go from 80 to 120, right, there's still a lot of people here, but how many people have high IQs bigger than 120? or less than 80. And the farther away you get from the average, the less and less and less people are going to fall into that range. Okay, so that's why we calculate z-scores, is because we don't want to, I don't want to carry these numbers around in my head. That's hard. Okay, 1, 2, or 3, that's easy. Okay, but figuring out a different, like, well, I have to know the average and the standard deviation for each and every thing I'm going to study, that's too much information to carry around. So what the z-scores allows us to do is turn everything into if I take the average, x minus mu divided by sigma, right? If my x happened to be average, mu minus mu divided by sigma, that would be 0. I don't care what it's over, it's just over 0. It's just going to be equal to 0. So that tells me that the average score is a z-score of 0. There's going to be a lot of people or a lot of observations around 0. Not so many. The further we go out, the less and less and less it's going to be. Okay, and that's positive and negative, right? So it's important to remember that that's why we use the z-score, is it tells us how many standard deviations away from the mean that we are. If you're like, that didn't make a lot of sense, you are not alone. That is a very difficult concept for students when you're first getting it, to like try to cast things in terms of z-scores. As you do a couple of problems, you're going to get a little bit better at doing this, because we're going to think that way. And what I really want you to do, like at the end of the class, or at least at the end of this unit, is when you're looking at an observation, it's like, well, how many standard deviations from the mean are we? And we're always going to count in those standard deviations. So if my footstep happens to be 1 foot, then I can count in terms of 1 footsteps. But if my footstep, maybe I've got a wider stride or something, or maybe I'm jumping, I'm not just taking footsteps, my standard deviation is like 3, and my stride is now 3 feet, then I'm going to be talking about in terms of how many 3-foot groups am I away from the average. Okay, so that's what our z-score is trying to do, is trying to standardize this thing, so we only have to deal with 0 and 1. But the way we do that is use this formula, z equals x minus mu divided by sigma. Okay, I'm trying to come up with a way of putting this kind of stuff on. I don't think I really need to add this formula to you guys for a quiz. I don't care if I do. I would provide this for you. Okay, that z is equal to x minus mu divided by sigma. But that's pretty much what we're doing. So when they want to know what z for the x squared 68, okay, what I would like to know is, like, well, we need to know what the mean and the standard deviation is in order for us to do this. So if we're given, okay, if I'm given that the mean is, right, they give us that, they say the mean is equal to 58, and the standard deviation is 20, what is the z-score for 68? So we're going to say, okay, well, x equals 68, therefore our z-score is z is equal to x minus mu. If you really need to memorize this formula, okay, I try to minimize the number of formulas you really have to memorize. So if I can make an extra question to write this down, I will. Okay, because I don't think statistics in the 21st century shouldn't be about memorizing formulas. Okay, but it helps if you write it down first. That tends to help. So they wanted to know x equals, what did they want to know? X equals 68. Okay, it would be nice if I wrote 68. So we want 68 minus our average was 58 and divided by 20. Okay, 68 minus 58, that was just 10, right? Divided by 20, we're going to go ahead and cancel that. So we end up with 1/2. So we have a z-score of 1/2 for this particular measurement. Okay, so we'll go ahead and type that in. So we have the z-score is 0.5. So we'll put the 0.5 in there. We'll put the leading 0 just for best practices. Okay, so 68 is 0.5 standard deviations away from the mean. Okay, it's actually above because it's a positive number. If it was lower than the mean, it would be a negative number. Okay, and that's just how we identify that. There's no judgment here on positive or negative. Okay, it's just a positive number. It's above the mean. It's a bigger number. Okay, check, yay, we get the green light, and then we'll go on. Okay, so I hope that helps like get you to at least start thinking about z-scores that way. Again, it's helpful if you always write down the formula before you do the calculation. That tends to help you memorize it, tend to help your memory with it. And I would recommend doing that because we're going to use it a lot. But if you're stressing out over memorizing this formula, like don't stress out over memorizing it. I would provide it to you. Okay, so I hope that helps a little bit, and I will see you in the next video. Thank you.